In this video, we want to talk about the proof or sketch of the proof of sine and cosine of a sum. So let's start with angle alpha and angle beta. Let's concatenate the two of them together so you can see that COA is angle A alpha and AOB is angle beta, and then COB is the angle alpha plus beta. Let's assume all the points and basically are points A, B, C are 1 unit away from the origin. They are on the unit circle basically. Let's try to first of all find the sine and cosine of angle beta. So let's drop a perpendicular from point B onto the other side of the angle. Now this length is going to be the sine of beta. That's BE is equal to sine of beta. And this other length from O to E is going to be cosine of beta. Not from O to A, but O to E is going to be cosine of beta because the hypotenuse is equal to 1. Now, let's drop a perpendicular from point B to the x-axis, and that will give me the sine and cosine of the sum of the two angles. So in this case, this side is the BD is equal to sine of alpha plus beta, and OD is the cosine of alpha plus beta. So what is remaining in here now, because I dropped two perpendicular, one to this side OA, right here OA, and the other one to OC. So the angle OA and OC are making is alpha, and the angle between the two perpendicular that I dropped should be also equal to alpha. Now from this alpha, let's try to drop another perpendicular, this time from this point into BD basically. Okay, now that I dropped this perpendicular, we knew already that BE we knew that it was equal to sine of beta. Now that's the hypotenuse for this little triangle over here with an angle alpha. So this side BF, and first of all, FE is going to be the hypotenuse times sine of alpha. That is, BF is going to be sine of beta, hypotenuse is sine of beta, times BE, is going to be sine of beta times sine of alpha. And then BF is going to be sine of beta times cosine of alpha. Now, let's continue. Now, if I drop another perpendicular from point E to the x-axis, here EG is basically OE times sine of alpha. What was OE? OE was cosine beta. So EG is going to be cosine beta times sine alpha. And similarly, because here there are too many, you can tell that there was a perpendicular over here and a perpendicular over there. So EG and FD are the same size. So FD is going to be equal to cosine beta times sine alpha. That's nice because then I will have this entire length done. One piece is FD, which is also equal to EG. That's one piece right here. And then the other piece is BF, and and we find BF to be sine beta cosine alpha. So if I actually write that down, looking over here, BD entirely was sine of alpha plus beta. So I get one of the formulas here. BD is equal to BF plus FD, and that's sine of beta cosine alpha plus cosine beta sine alpha. Now, OD, that is cosine of alpha plus beta, is equal to OG minus DG, and OG we found to be cosine beta cosine alpha, and DG, which is equal to FE, is equal to sine alpha and sine beta and sine alpha right there. And so these two prove the theorem for the sine and cosine of the, prove the identities for sine and cosine of a sum.